Hey everybody, it's hwsteele, and today is November 23rd, 2020. Let me ask you a question. Have you ever wondered why the number 3 and the number 7 seem to be so important for the Gann field and things to do with WD Gann, forecasting the markets, things of that nature? A lot of people know that they're important, but they might not know why they're important. The reality is there's multiple different reasons why those numbers are important, but in a purely mathematical sense, there's one reason that stands above all the other reasons as to why they are mathematically important. So I'm going to explain that in this video. So most of us understand a base 10 number system, 0 through 9, 10 different digits, and once you've reached that 10th digit, the number 9, you start counting over again at 11, 12, 13. So technically, it's 10 different digits, 3, 4, 5, 6, 7, 8, 9, 10, but the actual digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. At that point, we start counting a second group of 10, and that starts with the number 10. And then we count 11, 12, 13, and I don't have to go on and on, 14, and then we understand that it keeps going from there, like that. So that our second digit right here, the furthest digit on the left, tells us which group of 10 that we're in. And technically, this tells us, the number 1 over here tells us that we're in our second group of 10. And in our 20s, we're in our third groups of 10, all the way up till we hit 99, and then we get to the number 100. And 100 tells us that we have 10 groups of 10 numbers, and we're starting our 11th group. So we named the numbers something slightly different. So 0 through 9 is the basic names, and then we call them 10, 11, 12, 13, 14 to represent the fact that those are the same 0 through 9 rather, but in the second group of 10. Then we call it 20s and 30s and 40s and so on and so on. Well, if we switch to a base 7 number system, and I'm going to explain this a little bit overly simplified so that hopefully everyone will be able to understand it, or the theory behind it, basically. So it might not be mathematically 100% correct in terminology, but the number, the counting behind it is correct. So if we go to a base 7 number system, we have 1, 2, 3, 4, 5, 6, 7 digits, and those would be represented as 0, 1, 2, 3, 4, 5, and 6. That's 2, 4, 6, 7 different digits. So in a base 7 number system, we would stop counting single digits at 6, and we would start counting the second group of 7 digits. So it would be 10, then 11, then 12, then 13, then 14, then 15, then 16. And we would do that all the way up to the point where we got to 60s. So we would have the 60, 61, 62, 63, 64, 65, and then 66. At which point we would start counting at 100, theoretically. If we named the numbers the same thing, that's what we would be at. We'd be at 100, and this would tell us that we've had 7 groups of 7 numbers, and we are now in our 8th group, which means we have to have a third number position to represent this. So the number 7, 7 times 7, is 49, right? So in a base 7 number system, we would have 7 groups of 7 numbers before we increase to a third position to represent our number. And 7 times 7 is 49, which is the closest number to half of the value of the decimal system. So in the decimal system, or the one that we all pretty much know and use in this, in quotes, advanced civilized world, whatever you want to call it, in pretty much everywhere uses the base 10. Even if they use other number systems, they pretty much still understand the base 10 number system. And that's what science uses and all this good stuff, mathematics, world round. So the point is, in our base 10 number system, there are 100 numbers before we get to our third place where we start counting 100. The base 7 number system uses 1/2 the number of positions that the base 10 number system uses. So the base 7 number system is 50% the value of this system when it gets to third digits. Okay? So in a base 3 number system, let's go home, we have 1, 2, 3 numbers, and then we start counting again. So it would look like this. 0, 1, 2. And then we would start counting 10, 11, 12. Again, in theory, if we were still using the same numbers right here. So we would do this, and let's go ahead and do this right here. So we have 0, 1, 2. Then we'd have 10, 11, 12. And then we'd have 20, 21, and 22. At which point we've had our 3 groups of 3 numbers, so we have to start our third place of numbers. So we would be at this point at 100, then 101, and 102, and so on. So in the base 3 number system, you have 9 digits, which is the closest number base system to 1/10 of the decimal system. So hopefully you understand what I'm saying here. A base 10 number system has 100 digits to get to its third place, to where it has, the hundreds. A base 7 number system has 50% of that, or 1/2 of the numbers. It has 49, so it's slightly off, but it's the closest base number to get to 1/2. 3 is the closest base number to get to 1/10 of that, or 10%, a tithe of this number system. So hopefully all this makes sense to you, and you can understand mathematically, as far as the base 10, base 7, and base 3 number systems go, why, or I guess I should say one of the main reasons that the numbers 7 and 3 are important. And if you think about the use of the base 10, base 7, and base 3 number systems for a little bit, and you can do research online, just look it up in your web browser, and you can learn about different number systems, different base number systems. But keeping this concept in mind can be helpful when thinking about the markets, the stock markets, commodities markets, forex markets, so forth and so on. So anyway, hopefully you found this entertaining at the very least, and possibly slightly educational. And I will talk to you next week in the next video.